Alright, I have an update with the RMD-X7. This is my second attempt working with it, and this has to do with the servo control. So servo control actually works, restarting this, and the application will rotate, well first it's going to zero out, that's it, zeroing out, air quotes. It's going to rotate 360 one whole direction, then it's going to rotate 360 the other direction, it's going to rotate another 360 in that same direction, then it's going to go right back down to zero. In a split second it's also going to move right into 90 degrees. It's going to be important because I want to show something that I just discovered, which is that the encoder is actually attached to the input motor. So here we go, 0, and it goes a little bit further out from where the 0 used to be. I'm going to turn this thing off. Okay, I'm going to turn this back on, and we're going to get a new 0 point. So it resets to 0 point, but actually it is absolute encoding, because if I actually restart this and play again, it's going to just move slightly, ever so slightly. Check this out. Boom. So what I actually discovered is that we actually have a gear ratio from 1 to 6 on this motor, and I'm actually just going to go over here to the board. We basically have this issue here. So in the RMD-X7, we have this motor is the input motor, and then we have a gear shaft. This is 1 to 6 ratio. There is an absolute encoder on this side, so you can actually if you were to divide up the output up to 16 sections, you can do absolute encoding within each section here, but beyond that, it loses track. So if you stop somewhere in this area here, it'll resort to a center point in the middle of here, similar to how I kind of have it written up here. This is a bit of an issue because I was hoping that the 360 motion would be on the output shaft, so that when we do steering, we wouldn't have to do any type of weird calibration. We're probably going to do some calibration for the arm and its connections, maybe using like light sensor or light sensor or limit switch, or shoot, I mean the original idea was to use IMUs for it. So just use that to kind of get balance center and then move from there. The precision at the beginning is not super duper important. The main thing here is that I thought we could eliminate that, but because the motor here has the encoding on the input, we really don't know which section of these we're in whenever we turn on the motor, whenever we reboot the system. So we're going to need to use some type of feedback mechanism for all parts of the arm that use these motors, and then also for the drive steering system. I think something as simple as a limit switch, which I think is a bit much. I think something as simple as like a light switch, or some type of light reflectance thing that we could use, that could do this for us, would be perfect. But we shall look into that.